Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 16 to 20, which account for 21 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. (16A). Draw an enlargement of the shape below using a scale factor of 2 and 0, 0 as the centre of enlargement. So an enlargement means we're changing the size of this shape. It's a scale factor of 2, so we're making this shape 2 times bigger. So every side of this shape becomes 2 times bigger. But the important thing here is we have a centre of enlargement here at 0, 0. So we've got to make sure we enlarge from this centre. So there's a couple of ways you can do this, guys. What people like to do is draw what I call ray lines. So from that centre of enlargement through the corner, so each vertex of the shape, for starters, so like this, here, here, and here, because that helps us make sure we end up getting our shape in the right position on the grid. So now what we need to do is pick one of these corners. So I'm going to go with this corner here, and I'm going to plot its journey from the centre of enlargement. So it's gone 2 across and 1 up. So if I'm doing a scale factor of 2, that 2 across 1 up needs to double. So it becomes 4 across 2 up. So that tells me that this corner belongs here, and it goes on one of those ray lines. It happens to be the ray line going through that corner. So I know that that's the correct position for it to be in. Now what you can do at this point, if you want to, is do the same for each corner. So 3 across 1 up, double it becomes 6 across 2 up. Okay? And mark that point and do the same for each corner. Or because you have the ray lines, we know that this point is correct as a scale factor of 2. So this side of the shape would be, instead of 2, it would double for that scale factor to be 4. 1, 2, 3, 4. Look, that takes us to the ray line that joins up with this point here. So you can conduct the enlargement that way as well if you want to. That's why people find that ray lines are useful. So then from here to here is 1. On the enlarged version it's 2 because we've got a scale factor of 2. From here to here is 1, so we would go up 2, and it's there roughly on our ray lines, and then there we have it. So our shape, I'm just going to colour it in because I used pencil and you guys might not see it very clearly. Our shape is 2 times bigger in all dimensions, and it's correctly plotted on the grid with the centre of enlargement at 0, 0. Okay, part B. 3 vertices of a parallelogram have been plotted on the grid below. Plot the 4th vertex of the parallelogram. So these are our 3 vertices. So that's the 3 corners of our parallelogram. Okay. So our parallelogram has 2 sets of equal parallel sides. So this side here will have an equal parallel side here. This side here will have an equal parallel side here. So to find out where that 4th point goes, I'm just going to plot the journey from this corner to this corner, because that should be mirrored from this corner to the 4th corner of our parallelogram. So from here we go 1, 2, 3, 4, 5, and then up 1. So from here 1, 2, 3, 4, 5, and then up 1. So we expect our 4th corner to be there. Question 17. Amy and Vance each buy a thin pizza. Amy's pizza has a radius of 3 inches. Vance's pizza has a radius of 5 inches. Amy eats 1/2 of her pizza. Vance eats 1/4 of his pizza. So this is Amy, this is Vance. These aren't drawn to scale, so we can't measure anything directly from them. This is Amy's half of pizza that she ate, and this is Vance's 1/4 of a pizza that he ate. Who eats the slice of pizza with the greatest area, Amy or Vance? You must show all your working out. So we're not just going to tick a box from what we think, guys. We've got to show working out. So we're going to figure this out mathematically, okay? So we're working with area here now. So area of a circle is pi times the radius squared, okay? So we're going to find out the area that Amy ate of her pizza, the area that Vance ate of his pizza, and then compare them and see which is the greatest. So Amy's pizza has a radius of 3 inches. So Amy is pi times 3 squared, because our radius is 3. So pi times 3 squared is 9 pi. I'm going to write it as 9 pi for now in case I need to do any calculations with it later. Now Amy only eats half of her pizza, so we only want half of that area. So 1/2 times by our answer of 9 pi, which is 9/2 pi, or as a decimal, 14.137166994. Okay, let's deal with Vance. So we're going to find the full area of Vance's pizza. So it's pi times the radius squared. His radius is 5 inches, so that's 5 squared. Pi times 5 squared is 25 pi. But he only eats 1/4 of his pizza. So I'm going to do 1/4 multiplied by that area. So 1/4 multiplied by my answer is 25/4 pi, but I'm going to convert it to a decimal so I can compare it. 19.634954, okay? So who eats a slice of pizza with the greater area? Well, 19.6 is bigger than 14.13, so Vance ate the slice of pizza with the greater area. Question 18. The table below shows the mass of 90 carrots grown by a gardener. So we've got our mass ranges here, and then the number of carrots that had a mass within those ranges. Calculate an estimate for the mean mass of these carrots. So when we're estimating mean, we need to work with our midpoint, and then we use our midpoint to get some new frequency values to work with. So I'm adding in a midpoint column here. It doesn't matter whether you do it down here or up here, as long as it's nice and clear for them, guys. So the midpoint is halfway between the start and end point of these ranges. Now, if you can't spot that, add them together. So, oh, that's not very clear. There we go. So 30 plus 60 is 90, but when I half it, it tells me that my midpoint is 45. 60 plus 90, half it, 75. 90 plus 120, half it, 105. 120 plus 150, half it, 135. And then the last one, 150 plus 180, half it, 165. You might spot a pattern with these, but it's always worthwhile checking because sometimes they're not equal widths, and that can catch us out. Now we have the midpoint. We're going to multiply it by our frequencies to get our new frequencies. So we're going to do 45 times 9, so that's 405. 75 times 33. 105 times 38. 135 times 8. And then 165 times 2. So we're going to add these up now to get our new frequency total, guys. So 330 plus 1080. Be really careful here because this is where you could make mistakes entering things in. So that's 8,280. That's our total frequency. To estimate the mean, we do our total frequency divided by how many we had to start off with. So we're going to divide that by 90. So divide by 90 equals 92. So an estimate for the mean mass of these carrots is 92 grams. Question 19. Jan, Frida and Peter share some money. Frida gets 3 times as much as Jan. Peter gets half as much as Frida. Part A, write down the ratio of amounts of money that they each get give your answer in its simplest form. So here it tells us we want it to be in the order of Jan to Frida to Peter. So they've not really given us any amounts, but they've given us some really important information. So they've said that Frida has 3 times as much as Jan, but Peter gets half as much as Frida. So because Jan and Peter have both got a relationship with Frida, so we've got Jan, Frida, Peter. I'm going to say Frida's got 1, because that's a nice number to work with. If Frida's got 1, because that's what they both have in common, she has 3 times as much as Jan, okay? So Jan must have 1 divided by 3. Peter gets half as much as Frida, so Peter gets a half. Now we don't want fractions in our ratio, guys. We want whole numbers. So what we're going to do is we're going to multiply by 3 to get rid of the third. So 1/3 multiplied by 3 is 1. 1 multiplied by 3 is 3. And a half multiplied by 3 is 3/2. You can do that on your calculator. But then I'm going to multiply by 2. I didn't give myself a lot of space. So when I multiply by 2 to get rid of this fraction, 1 multiplied by 2 is 2. 3 multiplied by 2 is 6. And 3/2 multiplied by 2 gives me 3. So my ratio in its simplest form is 2 to 6 to 3. Part B. What fraction of money does Peter get? So we need to see how many parts we have in total. So 2 plus 6 plus 3 is 11. So there are 11 parts in total. So that goes on the bottom of our fraction. We're interested in Peter. Jan, Frida, Peter. Peter gets 3 parts. So Peter has 3 out of 11 as a fraction. Question 20. Samir buys this digger and expects to use it for 1,250 hours each year. The digger will decrease in value at a yearly rate of 18% of its value at the end of the previous year. Use this information to calculate the decrease in value of Sam's digger when it's been used for 10,000 hours. Okay. So he's going to use it for 1,250 hours a year. We're aiming for 10,000 hours in total. So if we do 10,000 divided by the number of hours per year, that will tell us how many years we're working with. Okay, so that's 8 years, guys. So we're calculating the decrease over 8 years, and it's going to decrease in value at a yearly rate of 18%. Okay, so its original value was 35,950, but we're going to multiply it by a percentage, by a decimal multiplier for this 18%. So if it decreases by 18%, we want 100% take away 18%. So 100 take away 18, we want 82%, guys. I want 82% as a decimal multiplier, so I'm going to divide that by 100. So as a decimal multiplier, it's 0.82. So I'm going to multiply the original value by 0.82, but I have to raise it to the value of the 8 years that we're calculating this for. So 3,950 multiplied by 0.82 to the power of 8. So that's 7,348.686387. Okay. We, guys, are working in money, so we want 2 decimal places. So that would be £7,348.69. Now, we want to calculate the decrease in value, not what its value will be, how much it's decreased. So we're going to take this from the original. So it started at 35,950, but after 8 years, it was worth the amount we've just calculated. So 35,950 subtract our answer is 28,601.31. So that is the decrease in value of Samir's digger when it's been used for 10,000 hours at a rate of 18% decrease each year.